Alright, Hythloday. Yeah, again. Well, like I said, it's the only conversation in town, so I guess we have to deal with it. But it's, yeah, I have my same objections. It's just these arrogant declarations, appeals to authority. We have a ton and ton. The evidence is just so overwhelming. You just can't possibly come up with anything to overwhelm these volumes and volumes of verifications, and it's just written in stone. So now he's obliging me to deal with Einstein-Lorentz as a definition of the math that's associated, and very indirectly associated, I would argue. I mean, highly strangled mathematics. And it's the same math that leads to the paradoxical circumstances where you could, see somebody die before you see somebody born, which, again, I'm arguing is evidence of a failure, not a success in your math, in your understanding of function. Yeah, I don't know whether there's too much here to deal with. This guy did post a mock-up of some of the implications of my argument regarding velocity and how it affects whatever might be considered some sort of time dilation. But Lorentz goes further than that anyway. It really is it's math regarding observation, and the observation is through the idea that light travels extra distance, but not in any real world. It always goes the shortest distance, and the shortest distance somehow is the longer path. Kind of crap. So anyway, I'll play this a little bit here, I guess, but I don't. He assumes that, and it's just an assumption, and he tells me what my theory predicts, right? I haven't even written up a prediction on the ratio of time dilation versus velocity. But I guess I would argue that it's probably going to be parallel to anything Einstein comes up with relative to the increase in velocity as a ratio of acceleration. So I think that's why Lorentz creates a funny curve, is that obviously the percentage of your velocity that's going to be due to your acceleration in a gravitational field, it's going to be a higher percentage in the beginning than it is at the end. At the end you have a very high velocity, and the added acceleration is very small. So it's like a meteor coming into Earth. It could be moving very, very fast, and the contribution of the Earth's gravity will be very minor to its overall velocity, and so it creates a curve where it means a lot in the beginning, and then it starts to mean nothing, and that's when it starts to go a straight line. So anyway, I don't see any reason why eventually it could be that the same scenario happens in what I'm describing, in terms of what percentage of velocity is acceleration. But I'm not really arguing about accelerating. As I pointed out before, as the thing gets harder and harder to hit, you have to use more and more energy to move it. So obviously it's going to have a curved line. It's really easy to move in the beginning and really hard to move at the end. So I think the curve is going to be the same kind of curve. So for you to presumptively say, he's basically saying that Lorentz does this and my curve does a straight line. I haven't even written the curve. I haven't even argued for the curve, and he's telling me already what the curve says. And I haven't even gotten to it yet, in the sense that it wasn't until just recently I realized that electrons don't maintain inertia. That is, they don't maintain velocity. That if you shot an electron into space, I'm arguing that it probably wouldn't keep going. It would stop. I think that's true. I mean, I haven't proven it yet. I I haven't analyzed enough information to be able to say it. But what I'm arguing is it's only material things, that is, things bigger than electrons, things associated with an electron, like a proton and an electron, can have actual velocity that's maintained. And that all the nuclear bits themselves can't maintain velocity. They have to be constantly accelerated. That's why accelerators have to keep accelerating, because the particle has no momentum. But that's the next video, so let's not get there yet. So I'll just play some of this, but I mean, it's just so pompous. Sorry, but I mean, I don't know what word to use for this. It's just so. I will declare for you what the truth is, and what the truth of your own theory is, and what you have stated when I haven't stated a damn thing. I haven't even tried to do a transformation. I haven't even attempted to be bothered with any of this crap, because I think it's totally unnecessary. Einstein's bent space is exactly the same as Mach gravity. The acceleration equations are exactly the same. There's no difference. So if all we're introducing is how the acceleration affects velocity, and then we're using this argument that velocity affects function, that is how you tell time, that is how fast a radioactive isotope decays, yeah, we could argue those things, but I'm just saying your expectation is that that's the focus of my attention, that I'm going to focus my attention on the details of radioactive decay at velocity when it's not even something that's easy to measure. I mean, it's really hard, I mean, people know this already, but it's really hard with very small particles to tell a change in their mass from a change in their momentum. It looks the same.
This is because they speak of space as an emergent property, but they're still bound by special relativity considerations.
Alright, so let's just understand. Special relativity is velocity based, general relativity is acceleration based. So it's almost the inverse. The special case is acceleration, and that's the one you call general, and the general case is velocity, which is the common thing. The common thing in terms of understanding something moving freely with an inertial state. So it's inertia. They call velocity inertia, which is kind of an inertial state, but it's not really an inertial state. It's not like velocity is inherently a something, not a nothing, especially by my theory. Velocity is something the thing is doing. It has a velocity as part of its function. Velocity isn't something happening to it. It's something it's doing in the universe.
In quantum mechanics.
Sorry about the volume.
They're talking about space-time being emergent from the vacuum and entanglement principles.
Yeah, and again, why should I care about any of that crap? Okay, that's like a Tesla ether or something. This is just crap. Okay, so they say they create time and some other bullshit out of some kind of bullshit they make, skunk juice or something. Why should I give a fuck about nonsense? I think that's all fairy tale talk. That's like telling me the life cycle of a pixie. I just couldn't care less about life cycles of pixies.
So again, I implore.
Oh, implore. I mean, this is something I really should have to focus all my attention on, is Einstein-Lorentz pixie fairy stories about where space is created or something. Some kind of crap like that, when I don't buy any of that shit. I don't think space is expanding. I don't think space is a something. It's a fucking nothing. The matter is the something. The energy is the something. That is, the forces and matter. That's the only stuff in the universe is forces, matter, and nothing. That's the mixture. No pixies. And you're saying this should be my focus of my attention. I'm trying to get you to defend the fact that they can't even accurately describe the simplest fucking experiments in physics, that is the two-slit experiment. They can't even come up with a rational explanation for the simplest experiments in physics, and then you want to sit there and tell me that I have to analyze all the assumptions built into the Lorentz transformation, for fuck's sake. No, I don't have to do that. No, I don't think you're imploring me to waste my goddamn time in that fucking minutia.
You can't just ignore.
Yeah, I can. Okay, but you know what I mean? I think somewhere between Newton and Einstein, there was no need for Lorentz transformations. Okay, the basic function was nailed by Newton, and we know that. It's 99% of the game, and this little minutia crap about some stupid pixie theory about how the space is bending and warping, especially in circumstances that we can't even test because it's outside the realm of a rational test. This is all just such a pile of crap. I implore you to make arguments to me that have something to do with my fundamental argument, okay, that matter is made out of a force. The force is made of this quanta that has a consistent and rock-solid Planck-style reliability. And there is no random, and there is no fudge, and there is no bullshit. It's all a frickin' mechanical device. Once initiated into process, it will continue to process. Once imbalance is created, it will remain imbalanced for the foreseeable future.
The discrepancy in predictions.
Okay, again, you're saying there's a discrepancy. You have no evidence of a discrepancy. I have drawn no chart. I have made no mathematics. I have no prediction about the exact way that velocity affects the complex function of the material relationships between electrons and protons, because that's what's creating the velocity. The electrons don't have inertia, the protons don't have inertia or momentum, but the two of them combined do. They're two magnets swinging around each other, and through that process they create what's called your velocity. It's a current.
I'd like to. Something tangent on the recent videos, I can't get my head around it. I do trust them, but I can't explain it.
Yeah, well, again, this whole idea of I do trust them is the part that I'm just finding incredible, okay? As I've shown you the evidence. Their lensing evidence is crap, okay? Their two-slit wave phenomenon evidence is crap when analyzed, obviously in the single-slit experiment most dramatically, compared to the single slit with water waves. The wave phenomenon is not reliable. It does not consistent.
Why there isn't, when the two waves cancel out in the interferometer, why there isn't loss of energy?
Because when they're not canceling out, when the light's going to the banded regions, there's twice as much light there. Or else the light is going back into the laser. So again, what's complicated? When you actually see it going back, I mean, he's conceding the point. Yes, there's a bunch of light going back into the laser. That's why he put the second interferometer there, and it demonstrates the fact that, yeah, like half the light just went back into the laser.
Why it doesn't break the energy conservation principles.
Well, I think I drew this diagram, and I don't know why this wasn't satisfactory to you, but it seems to me that it seems obvious that the conservation is being remained, because whatever isn't in any of these places is obviously going back in the laser. I mean, we didn't even get into the fact that this all involves polarization too, which is just makes the whole thing that much more complicated, because every one of these, every time light goes through this interferometer, the polarization is shifted. So whatever goes through the interferometer is polarized one way predominantly, and whatever reflects is polarized the opposite way, which makes this even harder to calculate. I mean, but to make these absolute statements about what is proven, still making these statements based on, it just seems obnoxious. And then again, I can look at the images you're showing, right? So you're putting this crap up as if it demonstrates something. None of these things are accurate. These spaceship things are so stupid because they show this jagged line. Well, the light never gets to this target, so it could never be measured anyway. And that's the truth of it. The ship is moving away. The light never hits. You can't create a clock. No clock will survive high velocity. It can't. Because light can't survive it. And light is the most foundational element of the realization of the material connection. The material connection to time all goes through light, so to speak. Tons, like the consequences of radioactive decay. All right, anyway, it's a ton function. All right, so let's go to the next one. All right, so this one was called Amendum Discrepancy 2, blah, 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 blah. So now it's this HLC thing. And so you can't get my premise arguments correct, ever. And so again, more wrong assumptions, and they're his assumptions about what I have said, because they have nothing to do with anything I have actually said. So we'll play some of this crap. I didn't even watch this one further, because once he starts with these wrong presumptions, you're just saying, what's the point? I don't say that. That's not what I believe. It's not what I've stated.
Speed of light, disintegration of matter. They shouldn't see anything but the same.
Alright, so the argument here is that I've pointed out that when they accelerate a particle, and then they have these collisions, right? So they take two protons, accelerate them in opposite directions, and then smash them into each other. Now, how do they see what happens? They see what happens because it's in a cloud chamber, essentially. It's in a seeing vessel. So the collision happens in a field that has other matter in it. And it's basically watching what happens to the other matter when all the little bits start flying out and hitting it. So that's how they see the collision. They see how it affects other matter. They're not seeing the proton just hitting the proton and that's all they're looking at. They're seeing the radiation, the pieces that come off, by seeing how they affect matter. So that's the first argument I would make. His argument is basically, well, how can they see anything if it's just force against force? If it's just, if it's light against light. Well, obviously it's not light against light because they don't achieve the speed of light. So the thing is still in some kind of form that's something like not light yet. And I would argue, though, that regardless, even if they did turn it into light, as I argued, the energy of that proton now is really, really high. And so in this environment, it's going to look like an explosion even if it didn't explode. Even if you didn't crash the two protons into each other, the fact that you're putting that much energy into the viewing field would create the same results. So if I actually could make a laser beam and shine it into that cloud chamber, the modified high-tech cloud chamber, it would produce the same effect in the sense that once I put that much energy in, I'm going to fuck the matter up all kinds of ways. And all kinds of little stuff is going to shoot out of it. So the cloud chamber is going to be just as excited whether I shoot fragments of proton or whether I shoot just plain force, high energy light or high energy tons, a large volume of tons at high frequency. That's obviously going to affect the cloud chamber, the eyeball.
According to your theory,
so again, according to my theory, so he just keeps saying my theory said something my theory doesn't say. He draws assumptions, he draws presumptions, and then puts them in my mouth and says that's the consequence of my theory, and it's not, as I just explained.
Shouldn't work of any fashion
Again, says you. The real question is let's see them accelerate a proton to, say, 3/4 the speed of light, and then slow it down and see if they get a proton back. I mean, physics is supposed to be reversible, right? Well, why don't you take a proton all the way up to the edge of the speed of light and then bring it back?
They shouldn't see protons there, electrons there.
All the stuff they see is what happens to the matter they're viewing. They're watching the photographic film, so to speak, change. They're not watching the things changing the film. They're watching the film.
The whole lot should just be tearing apart.
Okay, well, I'm just going to end it there because, like I said, I don't agree with your assumption. You're thinking they're actually viewing just the protons hitting each other, and the viewer doesn't have anything to do with it. There doesn't have to be any recording film to see them. We can see them with our magic imagination or something. We can see them without the radiation having to hit anything. I'm saying no, the radiation is hitting something, and whether you disassemble two Volkswagens and then throw the pieces at each other at 100 miles an hour, or you leave them assembled, isn't going to make too much difference. That would be my argument. The parts that make up a Volkswagen and the actual Volkswagen, throwing the parts at each other or throwing the actual Volkswagens at each other, I don't know if you're going to be really able to detect the difference. Except for the fact that some pieces will still have bolts connecting them or something. But just theoretically, just from scatter alone, force making stuff move in directions, just based on how much energy is expended in pieces hitting pieces, you won't be able to tell the difference. So that's my refute of this false premise for this false argument. Okay, number 3, interferometer wave cancellation only. So essentially he says in this bit that this can only happen because of waves, and only waves can do this. And the whole theory of refraction isn't really wave-based. It's electron-based. The whole theory of reflection basically has to do with the whole perpendicular thing again, that electrons emit force perpendicular. Now, I would argue that it takes 2 electrons to create a reflection. That the first electron creates the perpendicular force. The perpendicular force accelerates a second electron, which when it decelerates, it emits the photon. And that creates the right angle. That creates the, well, not the right angle. That creates the angle of incidence equals the angle of reflection, because it is essentially perpendicular. The reflection is perpendicular to the first angle. And because that's what electrons do. But again, I would argue there's 2 electrons involved in the reflection. But there's no need for a wave anywhere in there. And again, I've pointed out how the difference is. It's like, say, if I had a lunar module or a spaceship going around the circle orbiting the moon. When I turned the re-entry rockets on, critically matters. I turn them on one point, I shoot back into the moon. I turn them on another point, I escape the gravity. And the same thing is true with electrons when being hit by photons. Now, if I hit them at a high frequency, they'll turn different than if I hit them at a lower, less frequently. So if there's a longer period of time between the impacts, it will change how much it rotates before it emits perpendicular radiation. So the angles will change based on when you hit, or when the engine is turned on. What position the electron's in when the second ton hits it.
Light cannot explain the phenomena. As you adjust the distance...
So again, he keeps saying these are things that cannot be done in some blah, 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 and he knows it because they told him so. So here you have this complex experiment with lots of stuff going on, right? Just the interferometer, the beam splitters themselves. Again, how can you deny the implications of the beam splitter itself? It's basically a diffraction grating between two prisms. And so you're going to tell me that that doesn't have anything to do with pattern making. Well, I'm going to say that's a little bit incredible.
Says if you accept that the principal beam splitter is in fact splitting the number of particles of light, then changing the distance on one of the legs will not result in the null light condition.
Well, again, whether or not there was a null light condition is part of what's being argued here. Again, I would argue that the giveaway is the fact that he had to move the mirror a good 1.5 inches, okay, to make the idea of the on-off banding visible. So we're really not, we're talking about a focal length, and we're talking about whether you're looking at the entire pattern or just the central maxima, so to speak, of the double slit experiment. You're going to see a very different thing if all you do is look at the central maxima and then compare the single slit to the double slit. Because all then you're going to see is a decrease or an increase in intensity. And that's pretty much what you saw. An increase and a decrease, in a conflict in intensity. You didn't see any kind of interference pattern because he essentially disabled it by being at the wrong focal length. And the very fact that it has a focal length, in my opinion, demonstrates that some other phenomenon is taking place, because frankly the interferometer should work exactly the same at any focal length. So at any position it should be just as sensitive. We know that just barely touching it is creating a whole frequency worth of deviation. The only way the on-off pattern could reverse when he's just touching the table is that a tiny change in the mirror has to be almost a complete wavelength change in the amount of light. So you explain that.
Will not result in the cancellation of the waves.
Well, again, so you're still operating from your theory that these are somehow waves that cancel, that somehow dark plus dark equals light, or light plus light equals dark. That's your crap, okay? What I'm arguing is it's still electrons that are causing all the deviation, okay? Nothing else but an electron can change the path of a photon. The photon has to hit an electron has to move crooked and re-emit the photon at the wrong angle. That's the only thing that's creating any of this. So there's no, I don't have any conservation problem. You do, okay? And I certainly don't give a crap about any kind of, you know, light plus light equals dark thing. None of that's happening. But I'm going to argue just from your own wave mechanic theory that what's happening, the quiet space, you can see what happened. The stuff that was supposed to be making the quiet thing a wave is now doubled right next door. Okay, the amplitude of the wave is doubled right next door. So obviously that's where the energy went. The energy didn't go nowhere. It went right next door.
It isn't that all of the light, at that point the beam splitter stops working and puts all of the light back to the source.
Well, no one says it's all the light. The point is if you're doing an on-off thing and you say something's off, but there's actually a bright ring around the outside that you're not showing. So obviously the light is still there. You just took it out of the focal length, so you can't see it. But the light's still there. You've just eliminated it from view.
Not in a, you can't say that in the particular theory. What is happening is that the energy is, on one leg you have constructive interference and on the other you have destructive interference, which is the conservation of the energy.
Well, frankly, it's one interferometer, and I'm going to argue you can't have both going through the same interferometer at the same time. So whatever interference you have is going to be what you have. But I don't even want to get into an argument about what happens, whether or not the transmitted light through an interferometer, through a beam splitter, whether the transmitted light hasn't got a little tiny bit of deviation in its angle of refraction. It has a refraction angle, and that deviation alone isn't, I don't think, accounted for.
But if the beam splitter is truly...
that I would argue it's that transmission diffraction that creates the rings in the end, because the rings aren't really manifest until they shoot it through the lenses. So for you to just make all these assumptions based on what is really an experiment that has a lot of moving parts, for fuck's sake, and you're drawing these hard conclusions. This is absolute proof of something. I don't think so. And it's certainly not absolute proof that any conservation law has been violated.
Just a mechanical inert object which is splitting the number of photons and particles.
Well, again, we know it can't do that, right? It can't just benignly split them. It can't just say, half of you guys go over here, half of you guys go this way. Because we know that it's a diffraction pattern. It's already a diffraction grid. We know it's full of small apertures. So we know it's not doing anything benign. So we know the part that was reflected, okay, that didn't go through the two slits, so that might be okay. But the stuff that went through the slits, the holes, the thing that was transmitted, that is not only going through a refraction index problem because it's being transmitted, but besides the refraction problem, it just went through a diffraction grid.
You can't explain the cancellation.
There is no cancellation. There's a movement of light from one place to another place. Just even by your own wave theory, there's no cancellation. There's a movement. The light that was going to go there goes somewhere else. It's not like the light doesn't exist. It's not like the light annihilates. It's not light plus light equals dark. That's not really what happens. Light plus light equals jump over there.
Without a wave property of light.
Yeah, well, again, there's absolutely no need for a wave property of light. It's all electrons. The science of electrons is kind of known since Feynman. The very fact that they don't move straight has been known since Feynman. Feynman diagrams illustrate it perfectly. There's absolutely no, I don't need a wave here anywhere for you to say that absolutely has to be some sort of wave cancellation. Well, there isn't wave cancellation anyway. Again, I'll say to you, mechanical C waves going through mechanical C slits, okay? There's not a loss of force. There's no such thing as dark, quiet plus quiet equals quiet or whatever. There's no point as wave plus wave equals no wave. That's not what's happening. It's wave plus wave equals put the energy over there. Okay, anyway. I'm sorry. Whatever. Why should I apologize? Your style is obnoxious, arrogant, dismissive. You don't even, and based on words you put in my mouth that you can't quote me saying. And if you can quote me saying, they're obviously out of the context where, well, yeah, I said that accelerator experiments are just two protons banging into each other, and they get to see the parts that fly off without using a detector of any kind. No, the detector's sort of important again. You can't view things. You can't detect things. That's one of these problems we have. These are really little tiny things. You can't see them. You can only detect them. You can only fuck them. Or they have to fuck you. That's the only way to see them. Shit. Till next time. Yeah. Might be out of business for a little while. I don't know. This big winds here, storm coming and all that kind of crap. So, might be out of business for a while. Who knows? There's already a few roads closed, you know.